I'm done. 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 Okay. I'm really done. I said I'm done. By the time we're done here, we will examine the process TCP uses to close a session and some other fun TCP stuff along the way. Examining TCP in Wireshark is just downright fun. It really is. Until you get to the point where you're like, what's going on there? You start Googling a little while. Someone starts throwing RFCs at you because they're like, read the manual. Because everybody on the internet's angry for some reason. We don't know why. But they just want you to go read an RFC. And you're like, I don't want to read an RFC. Just tell me what it does in plain English. That's what I'm here to do. We've reached the point in the TCP conversation where it's time to close it down. And actually, there's multiple closes along the way. Let's bring up Wireshark and pick up where we left off in the previous videos. So we've been tracking over the last few videos a conversation between my computer 192.168.123 and a web server that was serving up a really simple web page. And we saw at the beginning how we had the SYN-ACK, the TCP three-way handshake to get the conversation started. We saw within that the sequence number and acknowledgement number used to keep it in sync. And then we saw in the last video windowing, where we looked at how much data the client and the server expects to receive. You can see our client is using a multiplier here because we see the window size is 1026, but multiplying that, scaling that by 256 to receive a whole bunch of data because it's the client, it's downloading, whereas the server on the other hand is kind of at a standoff position. It's protecting itself. It's saying, I'm a server, so I only accept a window size of about 4,300 kilobytes or so, 4,300 bytes, I should say, or so, before I cap it and expect an acknowledgement in between. That controls the pace of conversation. But let's continue on from there because we see now our client, that's me, 192.168.123, sending a GET request to the website saying, hey, I just want this example of a simple web page. Server flips back and responds and starts sending data. I know it's got some data in there because I looked at the length and I go, ooh, that's some meaty stuff. And so we're seeing data being sent and acknowledged along the way. And then every now and then we see this little psh. What's that? It's like, you know, when you're talking about a conversation, someone says something crazy, you're like, psh, whatever. That's not what it means here. You see a push packet right here. It's what it's short for. You see the flag right there in the acknowledgement saying the push value is set here. Scroll down a little ways. We see more conversation happening. We see a duplicate ACK, which probably means I need to get rid of the router at my house. So I just moved into this house. I'm kind of excited. That couch is going to go. I know it feels, you're like, are you like in your bedroom? No, this is going to be my office. It's growing. There's going to be stuff on the walls. It's going to be glorious. But as of right now, it's limited. And the guy who left his router. It's terrible. It's dropping stuff left and right. I just haven't had time to replace it. So that's why I see these duplicate ads coming in, because what this says to me is my router, maybe, I haven't investigated enough, but I've seen it enough to start going, okay, this thing needs to be a real network. My router is not able to keep up. So the server is finding the need to say, hey, I'm going to send some duplicate acts, or I'm just notifying you that you're sending me duplicate acts. So I see those along the way. And then there's another one. Psh, what's that? Okay. Psh. What are all these psh, psh, psh? What are these push flags? Well, simply put, think of communicating with TCP almost like I think of I never had any military background. I know a lot of people have had, and they've described, some of the conversations they'll be having. They'll either be doing Morse code, and obviously I'm way off the beaten path. Morse code, and they're kind of saying, okay, end that sentence, end that word. They send little end messages along the way. That's the push. The push says to the receiving device, hey, I know it's up to you when you want to deal with that data. I want you to deal with it right now. Remember our scenario. We've got our client that's receiving data from the server. And it's pretty much just sending data, and acknowledgments are coming back, but the server's leaving it up to the client to pretty much decide when he wants to deal with that data. The client might be just storing it all in a memory buffer. And as the data is coming in, it's like, we're just going to kind of keep it right there. And the server says, well, you know what? There's certain points where I want you to send it to the application. Push. Now, the client might have been doing that all along. The server doesn't really know, doesn't really care. It's just saying, okay, I've sent a good chunk of data. Maybe that's one portion of the web page. Maybe it's a JPEG image. Maybe it's whatever. Whatever segment the server decides to say, okay, that's a chunk of data. I want you to pass that to the application so it deals with that. In our web browser, it might be a whole bunch of pieces of the web page that, are popping up piece by piece by piece. The push message is a gentle close. Think of it just like, okay, got that, got that, got that. Remember how I opened the video? I said, I'm done, I'm done, I'm done. That's the push. When I said, I'm really done, that's where it was saying finish, fin. Fin is what I would call closing gracefully. And I know somebody thought of that Star Wars character, Finn. Let's look at it in Wireshark. TCP sending its data, pushing, acknowledging, sending all the way down, and then we're done. We've reached the end of the conversation. I don't want to communicate anymore. My computer says, hey, I'm finished. The fin flag is set. Now, I don't see anything else, probably because I stopped the Wireshark capture too fast. Usually, closing gracefully, we've got our data going back and forth. The client computer's like, okay, I'm done. Or maybe the server's like, okay, I'm done. There's a little pause there, and the other side responds and goes, I'm done too. Fin the other direction. Somewhere in there is the wait, and I missed that just because I stopped the capture to examine it with you. When you see a fin, that's normal. It's closing gracefully. Life is good. We've been marching out our way. We've transferred our data. Let's close it down. But there's sometimes we have to go one step further. I'm back to my, I'm done. Okay, I'm really done. I said I'm done. That's the reset. Most of the time, the reset comes when something bad has happened. Maybe you've got the client that's communicating to the server's sending, and all of a sudden it stops receiving the acknowledgments back. Maybe the application crashed here or froze, or the processor got so bogged down it couldn't keep up with it, or the whole operating, power outage, bam, that thing goes down. TCP had a thing going. It's kind of like we were in a relationship, and then you just stopped talking to me. The good news is TCP doesn't shed tears for long. Lois here doesn't have much patience. As soon as those acknowledgments stop coming back, the server will say, I am resetting this connection. And that's necessary because, remember, every TCP session that a server has going and a client has going, either direction, means resources are being consumed. The processor, the applications have to consume memory, consume processor to keep that session going. If we've got too many idle sessions, that can bog the server down. As a matter of fact, a well-known denial of service attack is known as a SYN attack. Google it, SYN attack. It's where somebody sends a whole bunch of SYN messages. I want to talk. And the server's like, okay. And eventually exhausts the resources because it's trying to maintain all of these. It's known as a half-open TCP sessions. And it can't keep up with the normal traffic anymore. And the server's now out of commission. Denial of service. Thus, when you're troubleshooting TCP sessions, if you see reset messages, check it out. Again, it could go back to one of probably two or three things. One, the network is so congested, acknowledgments aren't getting through, session is falling apart, and somebody who wrote the operating system, who wrote the application said, if you lose X amount of data, just kill the connection and try setting it back up again. Reset. Could be the processor memory not able to respond. Data's not coming back in time. Again, reset, end that session. It could be that there's security mechanisms in place. There's a firewall that's seeing a lot of connections coming in. It's like, reset. It's trying to close them down. So reset messages usually mean something bad has happened or something's not happening, and the computer, the server, is taking action to make sure those sessions are all closed down. So you've now seen the process TCP uses to close a session and some other fun TCP stuff along the way. I hope this has been informative for you, and I'd like to thank you for viewing.